All right, welcome back. Let's talk about why the fundamental theorem of calculus works. So remember, the fundamental theorem of calculus, part 1, just said that if f was an antiderivative of little f, so f prime is little f, then the integral from a to b of little f dx was just capital F evaluated from a to b, and remember that was notation for f of b minus f of a. And we'd like to know why that's true. Okay? All right, so here's why. So, we have the integral from a to b, f of x dx. Well, little f is capital F prime, so that's the integral from a to b of f prime of x dx. And then we have an approximation with Riemann sums. So I'm going to write down a Riemann sum here, and I'm going to use, for the Riemann sum, I'm going to use delta x is b minus a all over capital N. And so delta x going to 0 is the same thing as saying n is going to infinity. And then we had a bunch of x sub j's. That was just a plus j copies of the delta x. Okay? So the Riemann sum says this integral is approximately the sum from j equals 1 to n f at x sub j delta x, oops, capital F prime here. All right, and the smaller delta x is, or the larger capital N is, the better that approximation is, and in the limit it becomes exact. So if we take the limit, it's inequality. All right, now we need to remember that f prime at x sub j, well, that's approximately this difference quotient. So it's f at x sub j minus f at xj minus 1 all over delta x. And again, the smaller delta x is, the closer this approximation is. And in the limit, it's exact. So this is the sum from j equals 1 to capital N, f at xj minus f at xj minus 1 all over delta x. You see we've got some canceling going on. So it's a sum from j equals 1 to capital N, f at xj minus f at xj minus 1. And this is actually called a telescoping sequence because if you write it out, it actually collapses. So the first term is f at x1 minus f at x0. The next term is f at x2 minus f at x1. The next term is f at x3 minus f at x2, and so forth, until the very last one gives f at xn minus 1 minus f at xn. And you see, every term has a bunch of cancellation in it. The 1's cancel here, the 2's cancel here, and likewise the 3's will cancel with the next term, and so forth, until at the very end, this is the one that's canceled by the previous term. And you see only 2 people survived, this guy and this guy. Ah, ratsa. So, I wrote this wrong. This was f at x capital N minus f at xn minus 1. And this was the guy that canceled with the previous term. So, altogether, these are the guys that survive. F at x capital N minus f at x0, which is exactly, remember, x sub n was the very last point, so that was b. And x0 is the very first point, so that's a. And so this is just f of x evaluated from a to b, just as we wanted in the fundamental theorem. And then you have to justify that taking the limits, everything becomes exact, but that's not hard to do. All right, that's why the fundamental theorem of calculus works. See ya.